Welcome, everyone. We're very excited about our first webinar ever. I'm going to present our speaker. So Elham M. Nouri is an environmental economist with a passion for sustainability and the circular economy. With a double degree master's in agriculture, food and environmental policy analysis, she has worked on projects related to environmental preservation and tackling climate change, ranging from carbon footprint modeling to assessing how climate change influences farmers' decision-making. Her goal is to bridge economic and environmental priorities to develop practical, sustainable solutions. So with that, I'm going to give you the floor, and yeah, really looking forward to everything you have to say about Bitcoin.
Thank you, Kiki, for the introduction, and good evening, everyone. As Kiki mentioned, I am Elham, and today I'll be discussing Bitcoin from an environmental perspective. I want to start the webinar by asking you to imagine a world where financial transactions are instant, borderless, and free from central control. Don't you think that it's a game changer? To be honest, I think it is, and this is the promise of Bitcoin and cryptocurrencies for the near future. But what is the hidden cost of this digital revolution? It's a significant environmental footprint, safe to say. To be responsible citizens, we need to learn more about these costs and consider them in our mental cost-benefit analysis when we want to invest in cryptocurrencies or trade on these platforms. And next slide, please. For this purpose, today we will explore how Bitcoin works, its energy consumption, its effect on our planet so far, and what we can do to mitigate its impact. To begin with, I can start explaining what cryptocurrencies are and then what Bitcoin is. Cryptocurrencies are digital or virtual currencies that use cryptography for security and operate on decentralized network based on blockchain technology. I think you've heard so many unfamiliar words, right? To elaborate on these complex words and this new concept, it's always good to start with an example. A perfect and popular example of cryptocurrencies is Bitcoin. That's why I put emphasis on Bitcoin in this webinar instead of cryptocurrencies in general. If I want to explain Bitcoin in the simplest term and relevant to our discussion, I can say because it is decentralized and digital, it allows people to send and receive money securely over the internet, and because it is scarce, it can be the ultimate store of values. Currently, it's a claim, but we'll see in the future or maybe near future. It is decentralized, meaning that it operates without a central authority such as banks or governments. This happens by using a peer-to-peer internet network to confirm transactions directly between users and eliminates the need for intermediary institutions. It is digital like your emails or any other application, anything that you have on your phone. And it means that it is so accessible. And it is scarce because there is only a total supply of 21 million BTC of Bitcoins all over the world. In parentheses, BTC is the unit for Bitcoin. And currently, if I'm not mistaken, as of March 2025, I think the price of one BTC is equal to 76,000 euros. So it's a huge number. And this makes Bitcoin almost impossible to inflate or manipulate. So safe to say, as I mentioned, it's the digital gold. And that's why we say it's the ultimate store of the value in the future. To understand how Bitcoin works, let's imagine that we want to become a new user of it and then go step by step together. We start with installing a Bitcoin wallet on our computer or phone, whatever you're comfortable with. And it automatically generates our first Bitcoin address, a unique identifier for our account. And then we can share this address with anyone we want to send or receive Bitcoin from. For the second step, let's initiate our first transaction. Every transaction between two Bitcoin addresses gets recorded as a line in a block. Think of blocks like, for example, pages in a notebook. These blocks are then chained together. Think of it as, for example, signing at the end of each page in this notebook, just your normal signature. We call this signature chaining. Of course, these are some simplification on the topic because it's kind of hard to explain it, and the technicality of the topic is not our focus. And therefore, I try to make it as simple as possible. To go back to our topic, and this continuous chain of blocks form a shared public ledger known as the blockchain. Blockchain is the notebook that I've just mentioned. And since this ledger is publicly accessible, Bitcoin is often called transparent or open source, which means in simple term, the blockchain is a public time-stamped record of all Bitcoin transactions organized in chronological order. Here on the slide, you can see one example of a Bitcoin transaction. It includes a hash, which is the unique identifier for this transaction, and we'll discuss it later. The transaction amount and fee, and the senders and recipients' addresses. Here it starts with something BC1Q9 something. And then you can view live examples of these transactions on blockchain.com. If you just search it now, you can see it. And this is what we mean when we say it's open source. For the third and last step, we should sign the transaction we made. Each time we send Bitcoin from one wallet to another, the transaction must be signed for security. Like, for example, when you sign a bank check. This signature is a mathematical proof that shows I'm the real owner of the wallet. To create this signature, we use something called a private key. It's a secret piece of data that only I, as the owner of the wallet, should know. And every Bitcoin address has its own unique private key. Think of it like the PIN of your bank account. Only you should know it. And but for the sake of transparency, we also have a public key that is mathematically related to the private key. And for each transaction, public key is included in the transaction data that is broadcasted to the Bitcoin network, where miners use it to verify the transaction by. So far, we created a wallet, obtained someone's wallet address, made a transaction, and signed it. But how does the system verify the validity of this transaction? How does it check whether I have sufficient Bitcoin for the transaction or whether I am the true owner of the account? We learned that Bitcoin is decentralized, meaning that there is no single person or bank in charge of verifying transactions. So who does it? That's where mining comes in. The mining process both validates transactions and make them unalterable. First, we need to know how does mining validate transactions. Miners check a few key things before adding a transaction to a block. First, does the sender have enough Bitcoin to send? And they do this by checking transaction history on the blockchain. Is the transaction properly signed with the sender's private key? And they verify the digital signature attached to each transaction using public key to do this and answer this question. Is the transaction trying to spend the same Bitcoin twice? In other words, is a double spend attempt happened? And they do this by comparing the input of that transaction with previous transactions. And in return of checking these questions and validating the truth of a transaction, they will receive the fee, the transaction fee that I showed you in the some slides ago, and they will receive it as the reward. And the second question that I mentioned, how can we answer that? How does mining make transactions unalterable? The answer is just one word, but it's not that easy. They can do this by hashing. To secure the blockchain, miners use computer power to solve complex mathematical puzzles by calculating the hash for each transaction and subsequently for each block. But what is a hash? Hash is like a digital fingerprint for data. It's a special code that changes completely if even the tiniest detail in it is altered. Since each block's hash links to the next, changing one block would require changing all the others. A nearly impossible thing to do due to the huge amount of computer power needed. Therefore, when a block is signed by a hash, we cannot change it at any cost or at any attempt. Miners use powerful computers to guess a hash that meets Bitcoin's rules in terms of complexity. This guessing game is called proof of work. The first miner to find the right hash gets to add a new block to the blockchain. For doing this, miners are rewarded with a block reward. Block reward is newly created Bitcoins that currently is equal to 6.25 BTC per block. So each miner that can generate the hash for the current block and generates the next block will receive 6.25 BTC, which is something around 600,000 euros currently, more or less, and it's a significant amount. So because of proof of work, POW, and because of its difficulty and expensive nature of doing this POW, it helps maintain system securely because of its difficulty and the expensive operation that is needed to do all this hashing. And therefore, it can prevent system fraud from any fraud. Essentially, the electricity consumed to generate hashes ensure the security of transaction within the system. So now we know that where does that electricity go when we talk about the energy hunger and electricity consumption of mining and making transaction in a Bitcoin platform. So far, we've learned how Bitcoin works and why it is energy hunger. But now we need to discuss that this energy consumption becomes particularly relevant because Bitcoin transactions are growing rapidly. As of 2025, daily transaction exceeded 500,000, and some analysts predict Bitcoin could reach 200,000 million per coin, per BTC. And this growth means more energy use, which worries us about sustainability so much. To grasp the scale of this concern, let's look at these statistics. Bitcoin mining consumed approximately 0.55% of global electricity in 2021, comparable to entire electricity consumption of nations like Sweden or Malaysia. Huge, right? But let's get deeper and see what was the impact of this energy consumption on air, water, and land. A United Nations study looked at Bitcoin mining in 76 countries between 2020 and 2021. The findings highlight three major impacts on air, land, and water. To better understand these findings, first, we review the definitions of related footprints. We have carbon footprint in this concept, which is the total amount of greenhouse gases generated by your actions. In the Bitcoin case, relying on fossil fuels such as coal and natural gas to produce a massive amount of electricity needed for mining is responsible for this carbon footprint. Water footprint, which is the total volume of fresh water used to produce the goods and services consumed. Here it refers to the total amount of water that is used for cooling systems that prevent mining facilities from overheating. And then we have land footprint, which is the amount of biologically productive land area required to support a population's consumption in the production chain. In this case, it refers to the total area of land used for data centers that house the mining equipments. The result of the study I've just mentioned reveals that the global Bitcoin mining network consumed 173.42 terawatt hours of electricity in this period. And this means that if Bitcoin was a country, its energy consumption would have ranked 27th in the world, ahead of a country like Pakistan, which has a population of over 230 million people. And to offset this footprint, 3.9 billion trees should be planted, covering an area almost equal to the area of the Netherlands, Switzerland, or Denmark, or 7% of the Amazon rainforest. And in the graph here, you can see the carbon footprint of each country. Bitcoin's water footprint was similar to the amount of water required to fill over 660,000 Olympic-sized swimming pools, enough to meet the current domestic water needs of more than 300 million people in rural sub-Saharan Africa. And the overall land footprint of the BTC mining network was more than 1,870 square kilometers, which is 1.4 times the area of the Los Angeles. In this slide, you can see the world's top 10 Bitcoin mining nations in 2022 until 2021, which are China, the United States, Kazakhstan, Russia, Malaysia, Canada, Germany, Iran, Ireland, and Singapore, which are responsible for 92 to 94% of Bitcoin's global carbon, water, and land footprints. Although these footprints are significant and need immediate action against them, Kaveh Madani, the study leader, has a quote that's worth considering while we think about Bitcoin and its environmental footprint. He says that our findings should not discourage the use of digital currencies. Instead, they should encourage us to invest in regulatory interventions and technological advancement that improve the efficiency of the global financial system without harming the environment. We'll discuss this recommendation thoroughly later. So far, we've discussed mining footprints. However, the environmental impact of Bitcoin is not just estimated based on mining alone. It can also be assessed through the impact of each Bitcoin transaction. For example, one study revealed that each Bitcoin transaction generates carbon emissions roughly equivalent to driving a gasoline-powered car between 1,600 and 2,600 kilometers. Another study, for example, found that a single Bitcoin transaction has a carbon footprint exceeding that of over 1 million Visa transactions. Therefore, even when evaluating Bitcoin's environmental footprint per transaction, it remains highly significant. The other aspect of Bitcoin's environmental footprint is its waste. Bitcoin mining devices last only about 1.29 years before becoming obsolete. Bitcoin generates around 30.7 kilotons of e-waste per year. And it's similar to the IT waste of Netherlands, and each Bitcoin transaction creates about 272 grams of e-waste due to discarded mining hardware. By mentioning all these negative impacts, we can conclude that Bitcoin's environmental footprint has several aspects. It includes mining, transactions, and e-waste. Giving it a scale, meaningful action and stronger policies are absolutely needed. To mitigate the environmental impacts of Bitcoin and cryptocurrencies in general, we can ask for these actions from our politicians. First, we can ask for increasing transparency in cryptocurrency mining and establishing tracking systems to monitor energy consumption and environmental footprints. Second, we can ask for increasing electricity prices for cryptocurrency mining to discourage excessive energy use and introduce taxes on crypto revenues and transactions. Third, we can ask for conducting more and more updated studies on this topic. The other recommendation can be promoting the development of energy-efficient cryptocurrency and encourage the adoption of greener blockchain validation protocols, such as transitioning from POW to proof of stake, which is POS. POS reduces the need for extensive computational resources, and it requires less participants. Ethereum, for instance, has transitions from POW to POS with its Ethereum 2.0 upgrade in 2022. And it significantly reduced its energy consumption and footprint by an impressive number of 99.99%, according to the Crypto Carbon Rating Institute, CCRI. So definitely with changing the structure, we can have a significant reduction in our energy consumption and thus reducing our environmental footprint in this area. And the next recommendation could be powering mining operations with renewable sources such as solar energy, wind energy, or hydroelectric power. And if I'm not mistaken, I think Canada and Ireland, they are currently investing on hydroelectric power to generate the needed electricity for their mining procedure. And the last recommendation could be balancing out carbon emissions by investing in projects that remove an equivalent amount of CO2 from the atmosphere. To conclude this presentation, I can say that Bitcoin's environmental impact is undeniable, definitely. While it has revolutionized digital finance, its reliance on energy-intensive POW creates sustainability challenges. However, through regulatory actions, technological advancement, and a shift toward renewable energy, we can mitigate its impact. It's a shared responsibility. Governments, corporations, and individuals must collaborate to ensure that the future of digital finance is both innovative and sustainable. Thank you so much for your time. I tried to keep it as short and concise as possible, and I hope this presentation has provided valuable insight into Bitcoin's environmental impacts. And these are the references that I have used in this presentation. And yes, if you wanted to review them, you can use them.
Thank you so much. That was very insightful. I would like to ask if anyone in the audience has any questions they would like to ask.
I have one.
Yeah, go for it.
Okay. So in the recommendations to reduce the impact on the climate with respect to Bitcoin, you mentioned different kinds of energies, wind, solar, etc. I'm wondering why nuclear is not suggested. Nuclear is a clean source of energy, and it's actually better than I won't say better, but so it's almost as good as solar, but it has more powerful output that it can produce and in a clean way. Do you have any comments on that? Or
Yes,
you can provide.
personally. Sorry, I interrupted you.
No, that is all. I just want to know your opinion. Yeah.
Yeah, personally, I am totally agree with you, and that's a really valid point. But because I used some resources as the reference of my words, and they only mentioned the solar, wind, and electric energies, I thought that it might be good to keep the recommendation based on the current published paper and scientific works. And then I just kept myself in the structure. But as you mentioned, there can be other alternatives, such as nuclear power as well.
Thank you very much. Are there any other questions?
Next one, I think the last point, fourth point in the recommendation slide, you said sustainability means an ETF. I think we tried to suggest, in that case, I want to know what ETF is. Is it trading funds? Can you elaborate on that?
Excuse me, have you asked the meaning of BTC?
No, but ETF you have under recommendations. I think it's the fourth point. Sustainable means, I cannot recall the exact sentence there. In the slides, it's the fourth point. It points to something called ETF. I'm just wondering if it's related to the financial instrument called ETF, which is trading fund, or is it something else?
No, it is exchange traded fund, as you mentioned.
Yeah. Okay. Thanks.
Okay. Does anyone else have any questions? I might go ahead and ask you a question then, if that's okay, because do you feel like there's an awareness in the crypto community for this? Like, is it talked about? Is it a priority, and is it taken seriously? Or do you feel like it is more talked about in environmental circles, but not so much in the crypto community?
My personal perspective is that it's not so much discussed in the financial markets because, there is a concept that each 4 years, the block reward will be cut in half. So as time passes, each reward that you can receive for mining and closing a block will reduce. And such thing increase the speed of participating in this and try to mine as much as Bitcoin as possible sooner, because later will be equal to less Bitcoin. Therefore, I think in a financial market, the mainstream activities is more guided by the financial and benefits incentives rather than environmental incentives. But in terms of policy making, as I mentioned, for example, if governments put more taxes on mining revenues or on mining procedure itself, on electricity, power, or forcing people to respect environment at this stage might be more helpful than, for example, increasing awareness, because as an individual, I don't think that we can ask them to disregard their own benefits, because I can say it's a really important part in extracting and mining Bitcoins.
Okay, thank you very much. I have one more question that I just want to check if anyone else in the audience has one more question. No, then I will go ahead because I feel like, oh, this is just slides actually, thank you. With the recommendations, they tend to focus mostly on mining from what I can see. But you also mentioned e-waste as a problem here. Are there any potential solutions that tackle that exactly that you are aware of? Do you know if anyone is trying to like address that element as well?
From my perspective, e-waste is a subsequent consequence of mining so much. So if we can reduce mining, we can reduce e-waste, because e-waste is generated because of the equipments and devices that are used in a mining procedure. The less we mine, the less devices and equipments we need, so the less e-waste we can produce. Therefore, I think to reduce the transaction footprint and also e-waste footprint, first we need to reduce the mining footprint. They're kind of chained together, and one is this sequence of the other.
Thank you very much. In that case, if there are no more questions, then I think all that is left for us to do is to say thank you so much for all your insights, and thank you for everyone for attending.
Thanks indeed.
Thank you so much.
Good question.
Thank you for attending, and I'm open to any more questions through emails or LinkedIn. That would be also more than welcome.